Hi, let's get started. First thing first, this course was given by Dr. Dapeng Wu, but I'm not Dr. Wu. It's because Dr. Wu was on his travel and his flight was canceled today, so I have to take place for this class. And this is the first class of this lecture, which is about image processing and computer vision. And as a routine, I will not talk about any specific technical details of any of the algorithms you will encounter in this course. However, what I will introduce is a brief introduction to what is image processing and what the course will look like. And another thing I want to emphasize on is what the grading policy. Many of you are interested how this course is going to be, how these gradings will be given to students, something like that. I think you guys may pay attention to the latter part. Okay, let's get started. So, as some of you may have already learned something or even have some hands-on experience on image processing and computer vision problems, what we are going to cover in this course is first, we will introduce some basic ideas and concepts about image processing. Then, because image processing is seamlessly integrated with computer vision problems, and computer vision has become a very popular topic in recent research trend. So we will also spend some time focusing on computer vision part. And also, it has an important component that is indispensable, which is video coding. You need to study coding in order to have your media, your images, or any other kind of multimedia to be stored on your disk. And also, we will have some very limited or very brief introduction for medical imaging, which is widely used in the recent medical treatment. So what is image processing? I think everybody in this classroom may be very familiar with all kinds of image processing technologies, such as you can nowadays, there are many apps that render this kind of capability in your cell phone and everything. So basically, what image processing is about is you can take original image and you do whatever transformation you can. For example, you can do rotation, you can do wave, swirl, or any other kind of a transformation or filtering to your image to whatever results you want. So it's like magic, right? So this is just a simple example of what image processing can do. It can generate images to whatever format you want. It can create using some advanced technologies to create what kind of effects you want as well. So for the image processing realm, there are many kinds of areas you can focus on. For example, the image processing includes the image acquisition process. This is like you have a camera and how you capture the image, and you take the image to your devices, your computer, your cell phone, and then you have the image as the source. And you can do image enhancement. For example, you can do contrast adjustment, brightness, and whatever kind of adjustment you do this image. And another is image restoration. For example, if you have a very blurred or damaged image, how do you reconstruct the information originally contained in the image? And of course, color image processing. This is a must. And the wavelength and the multi-resolution processing is something that you can do some frequency and any other component analysis and filtering in another domain in order to have your image processed in that way. And the image compression is very important. For example, you take very high resolution image. If you don't compress it, you cannot store it efficiently. And of course, the compression comprises of lossless and lossy compression. We will talk about this in this class later on. And of course, you can do morphological processing. Some of you might be very unfamiliar with this kind of term. Morphological processing is widely used in some pre-processing technologies. For example, you have to do some pre-processing to denoise, to have more clear images after. For example, you do some recognition tasks, you could do some computer vision tasks. This is a must. And of course, all these are based on pixel operations on your image. And then these parts, segmentation, representation, and description, and object recognition, these parts are in a sense of semantic analysis. That is, not only you do pixel operation on your image, you also have to derive the meaning behind the scenes. For example, you do segmentation. For example, you have a figure, you have a picture that there is a figure, there's a human being in a figure. You want to extract the human from the background. You can do segmentation. And of course, the representation and description is just like, for example, you have a picture containing a dog or the human. You just feed into the computer. Let the computer decide what the content is in this image. For example, the computer will say, oh, this is a dog. Oh, this is a cat, or something like that. So this is the image representation and description. And of course, object recognition. This, for example, face recognition or any other kinds of recognition are based on object recognition. These are semantic level, a higher level than just simple pixel operations. So this is the image processing techniques will give you if you can do all of these things. And the computer vision actually is based on the semantic level. For example, you can have the foreground be segmented from the background. The moving object, you can tracking them. You can do 3D reconstruction from multiple views. And you can also have structure from motion. And this is a demo of object tracking. You can track any kind of moving object, either human or any kind of cars object that you are interested in. And another aspect is video coding. I think the coding part basically has two categories. The first one is lossless image compression. Basically, you can use entropy coding. Some of you might be familiar with Huffman coding, something like that. This is the optimal coding you may encounter in lossless image compression. And another one is lossy image compression. This is much more familiar because every day you will use it. For example, the JPEG. JPEG uses DCT and it's lossy, but you don't really notice the difference between the original image and your compressed image because it discusses the most unnoticeable components. And another thing is transform-based compression. I already mentioned the DCT, right? This is used in JPEG. And there is a prediction-based compression. This is widely used in video coding. For example, there are advanced video codings. They not only use DCT to compress the pixels, but they also can extract the connection between frames. For example, if you have, I will take a simple as this one. For example, if you have this kind of image, the only moving part is the car. So the algorithm can smartly detect the moving part. And let's suppose the background is still, right? This algorithm can just extract the moving part and only encode the moving part, and the rest can be saved, can be taken from the previous frame. This is kind of like, this is called prediction-based compression. And also, we have compressive sensing. This is, I think this is pretty popular in recent years in the research directions because of the compressive sensing, sparse coding stuff that is widely used in deep learning. And the medical image, for medical image, we have the Radan transform, which is the basis of CT, computed tomography, and the MRI. These are also image technologies that can aid the doctors to diagnose diseases, right? Okay, so we are going to talk about multimedia because image and all other kinds of video things are closely related to multimedia. So what is multimedia? Why there is a so-called multimedia hype? The multimedia system plays a central role in society. You have TV, you have HD TV, you have hi-fi, Some of you may be some of you might not familiar with this term. This is some very professional sound systems that you can use in your home entertainment system. And of course, you have 3D animation, you have a virtual reality, and you have camera-equipped phones, so everyone becomes a news reporter. And you have camcorder surveillance systems that is widely used in various environments. And of course, you have DVD player and digital cinema. These are pretty familiar, right? So because there's a growing multimedia industry, and the multimedia actually is closely related to wireless communication and internet, and the future, of course, you know, all the TVs right now are digitized, right? So you can imagine whatever you think, that all is in the multimedia realm. So for the definition of a multimedia, we can see it basically consists of audio, still images, or moving images, text, graphics, or computer animations. So all these components and any other components that you will think of comprises this multimedia definition. So all the TV stations in US and TV sets so they are digitized. And in terms of the classification, we can classify it in two ways. The first is space-based. You have still images, you have pixels, these are in a space domain. And of course, you have text and graphics. They are also in the space domain. And the time-based, you have the sound, These have time. This is actually a time series, and you have animations. Have timeline, right? So the multimedia is actually the interdisciplinary area that has communication, computing, and broadcasting. So for the computing part, we have multimedia computer. We have 3D computers. You can use goggles or any holographic technologies. And you have virtual reality. You have image-based rendering. And for the communication, you have wireless networks. You have 4G. You have 5G. You have cell phone networks or whatever networks that connect you to the internet. So the multimedia technologies include, the first one is the compression. I just talked about the JPEG, JPEG 2000, and the MPEG 12345, and H.260X, and audio encoding, MP3, or any other kind of form you can think of. And image processing, computer vision, image understanding, and pattern recognition. This is semantic level of image processing I just talked about. And the most recent hype is virtual reality and the augmented reality. So this is the virtual reality. This is, I think this is the Oculus Gear VR made by Samsung. You can just use your cell phones, Samsung Galaxy S6, S7, whatever cell phones, to basically enjoy the simplest and the cheapest virtual reality stuff. And another one, everybody knows this. This is called augmented reality. And video streaming over internet. This is a research example, some research examples. These are actually people using this daily, but they don't know there are challenges and stuff that we are trying to solve. For example, we have video streaming over internet. There are many challenges that we need to solve in order to increase the reliability and the speed and whatever that you will encounter in your streaming. And of course, the error and the loss resilient video coding and transmission. This is another research direction. And power efficient video coding. This is also very important because everybody talks about power. Your cell phone needs to save power. The base stations, the communication infrastructures needs to save power. And another interesting stuff is multi-view video system. Basically, this is kind of like you can change views in whatever ways you want to enjoy the holographic or whatever video systems that you want to see. So there are many applications of the multi-view video. For example, the free viewpoint video, free viewpoint TVs, and entertainment. You have concerts, sports, multiple user games that you want to experience in different views. And you can use it in education. You can use it in sightseeing. For example, you want to enjoy the holographic of certain famous sightseeing, some attractions. And also, you have surveillance videos that you want to have a 360-degree angle of whatever in your surveillance. And you have archives, you have space archives, living national treasures, and you have any other things you can think of. This can be a very potential video technology that you can enjoy in the next few years. Actually, the 3D video, I don't want to talk about. Everybody has experience with the 3D, right? 3D movies or whatever, holographic stuff. And immersive TVs, this is something like if you have Gear VR, Oculus Gear VR, or any other things, you can enjoy it. Actually, I think in our school we have in the CISE lab they have Oculus, this kind of virtual reality devices you can try on, in the lab, in the library. I think it's Marston Library, and immersive teleconference, right? And interactive free viewpoint videos. So the theory behind this is you have many cameras that take the scenes in different angles, and you do some post-processing and composing together. Of course, you need to do some interpolation stuff, so you can freely change your viewpoint in a user's mind. So I want to show you a video of what these things look like.
At Interbe 2009, KDDI research.
こちらでは自由視点映像をご覧いただくことができます。自由視点映像というのは複数台のカメラで撮影した多視点の映像をもとに単純にカメラの映像を切り替えて表示するというだけではなくてカメラが置けないような場所から見た場合の映像を画像処理によって合成して表示するという点が特徴になります。そして、こちらご覧いただきます通り3次元空間上のあらゆる視点から見た場合の映像というものをこのように合成して表示することが可能となります。また、上下左右ですね、このように3次元空間上あらゆる視点からの、映像をご覧いただくことが可能となります。このようにですね、自由に視点を動かせる一方、ユーザーさんの方で自由にコメントのようなものを書き込んでいただくことができます。で視点に応じたコメントがこのようにですね向きも変わって表示されまして、例えば他の視点から見ている人のコメントが気になった場合はこの位置に移動ジャンプするということができます。こうすることで攻撃側と例えばこのボクシングの場合ですとディフェンス側とというさまざまな見方をしているユーザーのコメントを共有することができますので、また新たな映像の楽しみ方の一つになるのではないかなと思っています。
KDDI R&D Labs will continue enhancing this technology and reflecting users' needs in its development.
Okay. So the objective of this class is, of course, when you complete this course, the students should be able to know the fundamental technologies and for image processing. We will introduce various algorithms that is widely used, either some classic algorithms you may already familiar, for example, the denoising, the median filter, or any other kind of kernel operation that you might have experience with. And of course, we also want to introduce some advanced technologies that we are currently doing research on in this course. So for the video processing and computer vision. And of course, you should be able to understand the basics of analog and digital video, the video representation and the transmission. This is related to the video coding part. We will probably give lectures in the midpoint of this class. And of course, you will have the skills to acquire the basic skills of designing image and video compression. And you familiarize yourself with the video compression standards. We will introduce you several compression algorithms, the DCT, the wavelet, and any other kind of popular compression algorithms. Of course, the Huffman coding stuff, the basic stuff that will enrich you the experience of understanding how the video coding and the compression works. And everyone can make a design of image processing and communication systems. This is our final goal for you. And of course, but not everyone can make a good design. This is of course. And to achieve this, you need to have well-planned training and a detailed knowledge of theory of signal processing, communications, and network. I want to say that this course is not only about image processing. We will introduce a lot of other stuff related to multimedia technologies, which include signal processing, communications, and networking. We will talk about internet streaming, video streamings on internet, the problems, various kind of solutions to internet streaming stuff. So beyond image processing algorithms. And this is the syllabus. Okay, I will show you. So this is basically this is a very brief outline of what this course is going to look like. And another thing is I want to show you some other resources you might helpful. Yeah, you just clicking on the teaching link and you click on this one. You can find the syllabus here. This is the syllabus of this class. Course description, whatever things you just read about it. And this is the TA. I'm not a TA, right? I'm not a TA. This is not me. Yeah. TA, they have office hours if you have any questions. And they are also responsible for grading. Unfortunately, it's not me. So if you guys have grading problems, don't bother me. Okay. Another thing is I want to talk about is you can find the handouts here. When we finish certain lectures, we will put the handouts on this link. You can find it after class. And here comes the most important part, the course policies. We do not require every student to have a perfect, okay, I will make this a little larger. Hope everybody can see this. Yeah. Attendance. We do not require a perfect attendance for every student, but regular attendance is expected. So the grading of this class will have some part based on your attendance rate. Okay. So I think this is the most important one. Another thing is I want to focus. I can't emphasize more. I think, to my experience, every year there always have some students. They have late submissions. This class may be different from any other class you have attended. There's zero tolerance to any kind of late submissions. If you submit late, even for 1 second, this has great impact on your final grading. I hope you could remember this. I will say this again. No late submissions. I can't emphasize this more. And software reviews, of course, you know, you guys should have legal copies of your software. Otherwise, you take responsibility for yourself if you get caught. And the honest policy, I think this is also a very serious part we consider. We will consider any kind of plagiarism or any kind of dishonest behaviors, and this will greatly impact your score, your final grading as well. So you have to take this seriously. Okay, here comes the grading part. This, I think most of you the interest is focused on this, right? So we have homework for this course. We have homework. We have project proposals. We have project report. I think there are 6 homeworks you can expect. Homework 1, 2, 3, 4, 5, 6. Yeah, there are 6 homeworks. And every homework, we do not expect you to have any kind of late submission. So that if you submit late, basically that kind of homework will void your grade on that kind of homework. So you have to obey the submission deadlines. And of course, the project proposal, in the midterm, we will have you write a small report, maybe 2 pages long, about the final project you're gonna working on. This is called project proposal. And this, you shouldn't submit it late as well. And the project report, this comprises the largest part for your final grading. The project report consists of a written report for your project. That means you have to write a report that is in IEEE transaction format. So in case you don't know what is IEEE transaction format, well, you just can search IEEE template. Yeah, you can download either the LaTeX version, if you're familiar with LaTeX, or you can download the Word version, whatever. Just follow the template for your final report. And computer programs that you have to submit for this course, you can develop any kind of algorithms or anything you can think of. We do not limit any topics as long as it's related to this course. Actually, we encourage you to develop some complete and working code. For example, if you have interest, you can do some simple app developing. Such you can develop apps. There are many image processing apps out there. You can create one for yourself using the algorithms you learned in this class. We encourage you to develop apps for your cell phone. For example, you can develop apps for Android or iOS or whatever. Also, you can do some PC platform, the apps for your PC as well. And the programming language, we do not limit any kind of programming language. If you are in a preliminary level, you can do MATLAB, you can do Python, you can do C++, Java, or whatever language. So, and another thing is you have to submit a PowerPoint file for your representation. The thing is you have to do a presentation for your work. That is, you have to record it. You just do the presentation. You have to do the PowerPoint files, and you just speak to your computer, speak to your camera, and you record it, and then you upload the video to the YouTube. And this link, YouTube link, you also have to be submit this link through the e-learning system. I will show you a demo what this presentation will look like. You can see there are many students, the past students, they have do various kind of very good demos. You can click on anyone and to see how they do their work. But basically, they have first you have created the PowerPoint files, and you present it, you record it, then you upload it to the YouTube, and you give us the link. This will actually, I will tell you that the TAs, they will very interested in this video because this is a better way to present your work, right? So maybe your report is long. You have to write a very specific, very technical report, but maybe 10 pages long. And for, this is a large class, more than 100 people attending this class. The TAs, they have very large workload. So they prefer to watch these videos instead of reading through your long report. So you guys know what to do, right? So you have to present your work, and afterwards you show your code demo, how your code runs on your computer or whatever. If you have made an app, you can show how the apps run on your cell phone or whatever. And then you can do some analysis or whatever. You can watch any of the videos. You just type the keywords here. Okay. Okay. The grading scale. We won't give everybody A. I think this is pretty. Some people might not be very comfortable with our policy here because many classes in other departments, in the CIS department, they give a lot of A's, but we will limit the percentage of students getting A. So roughly there are 30% students, I think it's 30%. Students will receive A, and this will determined by your homework, project proposal, report, which of course the presentation, I think this it's 15% and 50% of written. And this one will give a first impression of how your work goes. So basically, I will suggest you to take seriously on the project stuff, especially the presentation, your code, your demo. You made it beautifully, and let the TA happy, and then you are good to go. Of course, I'm not a TA. You don't have to make me happy. The average score will be B+, of course. And of course, there are some students, they get B-. I don't think there is a C, but you can get B- if you don't work very well on your project. Yeah, this is my experience because I did TA in the last couple of years, but not this year, unfortunately. So I think this is, of course, I will emphasize once again, no late submissions. No late submissions. No late submissions. Okay, I think it's there is still a couple of minutes left. You guys have any questions or concerns or any specific things? You can just, yeah. No teamwork, individual project. Yeah, actually, if you must do in a teamwork, the individual team members will have individual report, individual stuff. You basically you cannot share the same copy of your code, the stuff, because we use the Turnitin system to check the plagiarism, the how to say, the rate of the similarity. So basically, if you share the same report, you will get 100% similarity. This roughly will give you to the B-, right? Yeah. Yeah, I think it's a very good idea to develop an app using to have several people working together to develop a working functional app. But you guys should focus on your part. The code submission, for example, if you develop an app, you usually have several source files. I don't think if you guys can separate this source file, for example, you take charge of one portion of the code line. We don't run your code. Actually, we only check out your code. Maybe read through some very briefly about your code. We don't actually run it. So you can just clip these parts, the snippet of your code that you work on, and the other people should have their own version of their code. You can just split that to different files and submit it. So you don't want to submit one copy that contains everything, because this will definitely cause, because the system is dumb, right? They just check the similarity. They don't care which part is done by you and which part is done by other person. So what you want to do is you want to separate them and make them into different files. We don't care about running your code, actually. We don't have time and energy. We have 120 people attending this class. If you want everybody's code, oh my gosh, So it's like you have to focus on your part, either the code you write or the project report you write. You have to focus on your part. You don't want to share the whole. For example, you guys may want to submit 10 pages of report that compress everything you make in this project. So you don't want to do that. You can split them into different chapters, and each person submit one chapter, and make sure that every chapter is different from each other. Actually, we have the maximum limit we can tolerate is 20. I think it's 20% of similarity. If you go over 20%, this will definitely have very serious impact on your final grading. You get my point? Okay. The homework. Actually, homework is pretty easy. Maybe I think there are some familiar faces taking these classes or similar classes in the last semester. They know that the homework is actually, maybe you should write. I think maybe tens of won't be over 100 lines of code. Just very small, very very small programs, and you submit the code. And I think some homeworks will include some problem-solving stuff. Will give you the problems. I think the problems will be on your textbook. The textbook we use is the Gonzalez version of. This is a very classic textbook for image processing. But we will not follow the outline of that textbook. But the problems we'll give it to you will be on that textbook, if there's any. So the problem basically, in simply put, the homework will have, some homework will have code. You have to submit the code. It can be either whatever language you use. For example, I think the first homework is you take a selfie of yourself and you convert it to black and white. Just one line of MATLAB code. Right? Easy enough? So just as simple as this one. So of course, there are some more complicated versions in the later part of this homework, but we hope you understand that this class is easy, and you don't have to take too much burden on this class. Yeah. Yeah, just some simple algorithms you might implement. And this is one part. Another one is problem solving. For example, we might give you a problem. You make some calculations and give us the results. Yeah, something like that. So you don't have to worry about this. I think it's pretty simple enough. If you guys are in graduate, I think all of you, this is a graduate course, of course. If you guys are in graduate level, you have absolutely no problem with any of these homework problems. Any other questions?
Who's the good-looking guy on your right?
All right, thank you.
That's me. Hi, I'm Walter Odell. I'm a researcher in radiation oncology. I'm going to be giving 5 or 6 of the guest lectures throughout the semester whenever Dr. Wu is away. Down. So I'm primary radiation oncology, cancer treatment. We do a lot of image processing related research. I have an affiliation with the biomedical engineering department. If you want to see more wacky medical imaging applications, Google me. There aren't very many Odells in radiation oncology research. And if I don't believe I will have any official office hours, even though I'll give lectures. But if you have interest in different applications of what you're doing in here and how that might apply, give me an email, give me something like that. That's it.
Yeah, if you are interested in medical imaging stuff, I think Dr. Dell,
Odell, yep.
yeah, Odell, would be helpful. Yeah. Any other questions or concerns or whatever you are interested or whatever? Because this is the class I teach, and I have several years of TAs on this course, which I might give you some information that Dr. Wu never will tell you. So if you have any, well, catch this experience, catch this opportunity to ask me questions. Yeah. Yeah, you can come here.
I'm taking this course because